Well, here we are. Pre-calculites, the very beginning of pre-calculus. It's taken us a long time to get here, hasn't it? Well, this chapter could be relabeled, Why You Do Math Anyway. Why do we learn all about this algebra and things like that? It's so that we can model an equation and problem solve and make predictions. When I worked for Energizer, one of the things we had to do is look at the data and come up with a projection. How much should our budget be for our different departments, and how much materials will we need for the factory if this trend continues? So it's coming up. So what we'll be doing is coming up with numeric models. Most of the time numeric models are just the data that you collect from your business. Algebraic models, that gives us something we can plug numbers into to make projections, and graphic models, which gives us a visual representation. So let's get started. On your pre-printed notes, you've got 3 types of models listed there: numerical, algebraic, graphical. We left out Victoria's Secret, but that's a different kind of model. Numeric model is a kind of mathematical model in which numbers or data are analyzed to gain insight into phenomena. Phenomena. Anybody with the Muppets knows that tune. Numbers or data is the key for it to be in a numeric model. This is a numeric model. We use numerical models to see if there's a pattern so that we can create an algebraic model to fit the data, which is what a lot of mathematicians do. To come up with the algebraic model, we use formulas to relate the variable quantities associated with the phenomena being studied. So if we look at this, variables are letters used to represent patterns. For example, area of a rectangle is length times width. You didn't have to discover that over and over and over again. You had an algebraic model so that you could just multiply those two together to figure out the square units of a rectangle. When we do linear regression to get the equation of a line, that's creating an algebraic model. We use algebraic models to make predictions based on previous patterns. It's useful for predicting weather. Speaking of weather, what a year we've had. Budgets, profit margins, population growth, and so on. This is where your mathematics actually gets applied to the real world. Graphical model, it's a visible representation of a numerical model. So you use a scatter plot, and you can also graph the function that you come up with. So here we start. Let's create from the mathematical model or the numerical model an algebraic and graphical model. What that means is we're going to come up with an algebraic equation or formula to represent the data, and we're going to graph it. So our algebraic model, the first thing you need to do is take out your graphing calculator. If you don't have your graphing calculator, pause this video and get it, because I'm going to take you step by step on creating this algebraic model, but we need to do it on the graphing calculator. So first off, you're going to go to the Stat button, which is right by your arrow keys, and you're going to select Edit, number 1. If you have something in these lists, you may need to clear those lists out. So if something was in my calculator in L1 and L2, and for our algebraic model, L1 is going to represent the X values, and L2 is going to represent the Y values. So what I did is I went to Stat again, and then I hit number 4, and then I did L1, L2. To get the L1 and the L2, you push the second button and the number 1 button on your calculator. So L1, L2, hit enter, and this is what your screen should look like. Now go back into Stat and Edit, and you will come up with a blank list. So there's L1 and L2 ready for your data. So here's the table of data. These are my X's in blue and my Y's in red. I'm going to go down and put a number 1 here and hit enter. And if you'll notice down here it says list 1, and this is the second entry in list 1, and we're going to put a 2, and then just go on down the list. So we're going to go 2, 3, 4, 5, 6, and then we're going to go over, arrow to the right, over to get to the Y column, the L2 column, and type in 39, 36, 31, 24, 15, and 4. Just pause this video till you get that done. Okay, so after your data is inputted, we need to determine our window size. And this is one of the biggest questions I get. How do you know your window size? Well, when you're given raw data, it's easy peasy, because all I do is I look at my data and I see what the smallest x is and the largest x is. That's how I come up with an x min and an x max. So I look at my smallest x is a 1, so I try to make that x min smaller than that so that I have a little playroom in there. The largest x is 6, so I make the x max bigger. So I went -1 to 10 for my x min and my x max. Next, I look at the y values. Well, 39 is the highest and 4 is the lowest, so I got to make sure that my y min is smaller than 4 and my y max is larger than 39. So I went from -1 to 50. I like to be a little bit generous with those ranges, because you might have to make a prediction on the graph and you can use it, and you don't want to have to go back and expand your window. So once you get your window set, you'll be ready to move to the next. Pause the video till you get there. Alright, third step, we need to make sure our stat plot is turned on. So I hit the second and the y equals button that's right underneath your screen, the left hand side. So second, and then I hit the y equals. It takes me to stat plots. If you notice, mine is off. So I'll hit number 1 and I will go to on and select on, and then I will have my stat plot turned on. And if you look up here, you have plot 1 there, and that tells you your plot 1 is turned on. If I go to my y equals button again, I've got a function in there. I need to clear that out. So you need to go arrow there and clear that out. Notice plot 1 is highlighted, so I know it'll be plotting my points. So clear any functions that are in the y equals. And now this is what your screen should look like. So pause it if you need a minute. Now, next step is going to be to graph. So if I hit the graph, I will get the plots of the points. Bada boom! Isn't that pretty? So then you have to decide what type of function would best fit the data points, a line or a parabola. Well, I can see this curving down. Some might say a line, but actually a parabola, I can see the curve in that. So we're going to do what's called a quadratic regression for this model. All the hard work's done. It's just a matter of pushing the right buttons. So you're going to go back to the stat menu and you're going to hit arrow to the calculate. So I went to stat and then I arrowed over to calculate, and then I'm going to select number 5 for quadratic regression. Then you need to type in second 1, which gives you the L1, then don't forget the comma, second 2, and then I would go to the vars button. This is my little trick. So you do second, then the number 1, comma, second, then the number 2, comma, then hit the vars button, which is right by your arrow keys, diagonal to the stat button. And then I'm going to hit the arrow to the y vars, and then hit number 1 and number 1 and enter. So that's what I should end up with. Quad regression L1, L2, Y1. Now, if you have a TI-84, it's not going to display like this. This video is for the TI-83 Plus. Once you hit enter again, it gives you the quadratic regression. And many students ask me when they see this -2.7 e to the -12. That means times 10 to the -12. When you see something like that, just say that's a 0, because that is a tiny number. That means a point, 0, 0, 0, 0, 0, 12 zeros, and then 27 at the end. So my quadratic, or my algebraic model for this data is actually the opposite of x squared plus 0x plus 40. I put a 0 in for the middle because this number is terribly small. So it's just the opposite of x squared plus 40. And because we put this little y1 at the end, it automatically puts it into your y equals 4. When we hit the graph button, this was what our scatter plot looked like. So when we hit y equals, it puts the whole equation up in here. I don't know why mine did -0.9999999, but if you scroll over, you'll see x squared and plus 40. Now, when I go ahead and graph that, it graphs the line right through those points, and you can see how close your model comes to your data points, which in this case, it's a very good model. The only one that it didn't quite go through is this one right here. What you can do with this is you can say, when is it going to be 0? When is the output going to be 0? You can go in between the points to make predictions and so on. So let's take a look at the graphical model. Let's take a minute to put this on your notes. So along the bottom, go ahead and number 1 through 6, and then along the y-axis, count by 5s, and then plot those points. So there is your scatter plot, and then go ahead and just draw your line through there. There's your graphical model for this particular table. All right, let's do a second example and see if you can kind of do this on your own. A physics student obtains the following data involving a ball rolling down an inclined plane, also known as a ramp to most skaters, where t is the elapsed time in seconds and y is the distance traveled in inches. Find an algebraic model to fit the data. So here's my x. X is usually representative of time. Here's my y. So first step, you go to Stat and Edit and type in your lists. So Stat and Edit, type those lists in. Like I said, you may need to pause the video. And then we're going to take a look at the scatter at the window. The window includes all of our data. I see no reason to change it, so I just leave the window as it is. By the way, to get to this window, there's a window button right under your screen. It's the second from the left. And then when we plot it, there it is. So you have to decide, should this be a linear model or a quadratic model? Well, you can kind of see the curve for the parabola. So this one is a quadratic model, and we'll do a quadratic regression, L1, comma L2, comma Y1. And then when we hit enter, this is what we ended up with. 1.2x squared plus bx plus 0x plus c. So our model is going to be y equals 1.2x squared. You have to write this. This y equals 1.2x squared is the algebraic model. Alrighty, so that's it for the graphing. When I graph this, boom, you can see that go right through our points. It only didn't go through that one right there. So all is well, and that's all we're going to do for today. I will put part 2 up about solving the equation algebraically and confirming graphically. But since we did the P3 through P7, you've already seen these. So you might be able to do those on your own. I will see you later.